In this video, we're going to learn how to solve quadratic equations. So the first thing we want to look at, we're going to set each equation equal to 0. We're going to factor, then we can set each factor equal to 0 and solve. So take a look at the first one. Notice it's already equal to 0. So all I need to do is find factors of 12 that add up to 8. So that's going to be x plus 6 and x plus 2. Now it says to set each factor equal to 0. So I'm going to find out what makes x plus 6 equal 0 and what makes x plus 2 equal 0. So on this side, I'm going to subtract 6 from both sides. X equals negative 6. And over here, I'm going to subtract 2 from both sides. And x equals negative 2. Those are my solutions to this equation. If I put in negative 6, that'll make it equal to 0. I'm going to show you. So we're going to take negative 6 squared, see how I put it in parentheses, plus 8 times negative 6 plus 12. It equals 0. And we can do the same thing with negative 2. So I'm just going to come up here and change all those negative 6's into negative 2's. And when I hit enter, I should also get 0. So I know those are solutions to this equation. Our next equation is very similar. X squared minus 9x plus 14 equals 0. I notice that it's already set equal to 0. So my job is to factor. What are the factors of 14 that add up to negative 9? That's going to be x minus 7 and x minus 2. So now I'm going to set each factor equal to 0. Add 7 to both sides, and x could be 7. Add 2 to both sides, and x could be 2. And those are my solutions to this equation. All right, let's do another one. This one says x squared plus 6x minus 27 equals 0. It's already set equal to 0. So my job is to find factors of negative 27 that add up to 6. So I'm just going to think about my factors of 27 and what they could be. It's either 1 times 27 or 3 times 9. So I think I'm going to go with x plus 9 and x minus 3. So I find out what makes x plus 9 equal 0 and what makes x minus 3 equal 0. So for this equation, it's negative 9. And for this equation, it's positive 3. Those are my solutions. All right, let's look at the next one. X squared minus 5x equals 66. Well, the first thing I notice here is it does not say equals 0. So I need to make it say equals 0. I'm going to subtract 66 from both sides. So now it says x squared minus 5x minus 66 equals 0. All I need to do is find factors of negative 66 that add up to 5. So if you need to look at your different factors, all of the possibilities, I think that about does it. I think I can get these two to add up to 5 if I use a negative 11 and a plus 6. So what makes x minus 11 equal 0? I'm going to say that's 11. What makes x plus 6 equal 0? I think that's negative 6. And again, you can check these in your calculator by plugging them in plug these values in for x and make sure they work. All right, let's see what's next. Well, next we have 2x squared minus 5x minus 12 equals 0. It is equal to 0 already, but I notice it's got a 2 in front, and it's not a GCF. So this is where, when we practiced, we went for this box method. So we start with our 2x squared in the corner, our negative 12 in the opposite corner. I need factors of negative 24, multiply those together, and they have to add up to negative 5. Now we could list those factors, or for a lot of us, we just went straight to our calculators and said y equals negative 24 divided by x. Except we wanted to say negative 24. There we go. Now if I hit second graph, it's going to give me a table. And my job is to search the table and find two numbers that add up to negative 5, because all of these numbers are factors of negative 24. So I'm going to look. Oh, I think I just found it. Positive 3 and negative 8. So 3x and negative 8x. And now we'll factor. What do these two have in common? 2x. What do these two have in common? 3. These two have an x, and these two have a negative 4. So there are my factors. That was a lot of work to get to the factored step, but now we can proceed to the third step, which was set each factor equal to 0. So I'm going to say, what makes 2x plus 3 equal 0? And what makes x minus 4 equal 0? So to solve this one, I need to subtract 3 from both sides. And then I'll divide both sides by 2. So this answer is negative 3 over 2. Now, if you want to make that say negative 1.5, that's fine. It's the exact same number. And this one, I'm going to add 4 to both sides. So x equals 4. And those are my two solutions to this quadratic equation. All right, the next one, it says 3x squared plus 11x equals negative 10. Well, the first thing I notice is it is not equal to 0. So I'm going to set it equal to 0 by adding 10 to both sides. So 3x squared plus 11x plus 10 equals 0. Now I have it equal to 0. Well, it's got a 3 in front, and it is not a GCF, kind of like the previous question. So we'll go to the box. So I have a 3x squared in the top corner and a 10 in the bottom corner. We're going to multiply those together. I need factors of 30 that add up to 11. So I think I know what those are, but if you can't think of them, then you go here and you say 30 divided by x and look at your list. I need to add up to 11. So let's see. There they are, 5 and 6. So 5x and 6x. And it doesn't matter which box you put those in, the answer is going to work out. What do these have in common? X. What do these have in common? 2. What do these have in common? 3x. And 5x and 10, that would be a 5. So I'm looking at 3x plus 5 and x plus 2 equals 0. So we set each of these factors equal to 0, and we solve. So over here, I subtract 5, and then I divide by 3. So this answer is negative 5/3. I'm going to ask you to leave it just like that because I don't want repeating decimals. The only other option would be if you wanted to write it as negative 1 2/3. But please don't put repeating decimals because we're in Algebra 2 now. Subtract 2 from both sides, and x equals negative 2. So those are examples of how to find the solution to a quadratic equation with factoring. What if I give you an equation and it doesn't factor? Or for that matter, any equation. There's this thing called the quadratic formula. The quadratic formula works on everything. So even if it can be factored, you can still do the quadratic formula, but it's especially helpful for the ones that don't factor at all. So notice first we want to set the equation equal to 0. It's got to say equals 0 before we apply this. Identify a, b, and c. Now in your equation, it's going to be in the form of ax squared plus bx plus c equals 0. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. We're going to substitute everything into the formula, and then we'll simplify the radical and see if we can reduce our fraction. Let's take a look. So notice this is equal to 0. So I'm going to identify a, what's the number in front of x squared? B, what's the number in front of x? And be careful with the sign. That's a +4, so this is positive. If it had been a -4, I would have put a negative. So from here, we're going to plug the numbers into our quadratic formula. X is equal to negative b. So this is a 4, so negative b would be -4. Plus or minus the square root of b squared minus 4ac all over 2a. So it's very careful that you follow your formula step by step when you put your numbers in. Now from here, I'm going to leave the -4 in front. 2 times 1 is 2 on the bottom. I'm going to take what's inside my radical and put it in my calculator. Now don't put the square root, just the numbers inside. So I'm going to put them in my calculator. Now I always put this first number in parentheses because if it's a negative, we've talked about when you square a negative, you always want to put it in parentheses. -4 times 1 times 2. And that's going to give me the square root of 8. Now, if I put the square root in the calculator, it's going to give me some decimal. And we're not looking for a decimal. We're going to stop at the square root of 8. Now, do you remember how to simplify the square root of 8? 8 is 4 times 2, and of course 4 is 2 times 2. So 2, I always go with buddies. 2 has a buddy, so it's going to go outside. This 2 doesn't have a buddy, so it's going to stay inside. So I'm going to end up with x equals -4 plus or minus 2 root 2 over 2. So the square root of 8 is equivalent to 2 root 2. And I'll demonstrate that for you. See, those are exactly equivalent. Now, notice that these are all, this, and this are all divisible by 2. So I'm going to divide everything by 2. -2 plus or minus, and 2 divided by 2 is 1. So I can just leave the square root of 2. And on the denominator, this 2 divided by 2 is 1. So this is my answer, completely simplified. Now my next one. I think this one could be factored, but we're practicing the quadratic formula now. So it works, quadratic formula works for everything. What is the a value? A is what's in front of x squared. B is what's in front of x. And C, this -3, is my constant. So here we go. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So take your time to write everything out, plugging them into the formula, which is provided for you. And now we're going to go through that same process. I'm going to put everything under the square root in my calculator, not the square root, just what's under it. So that's 5 squared minus 4 times 2 times -3. And that's going to give me the square root of 49. Ooh, I think I know the square root of 49. So the square root of 49 happens to be 7. So I have two answers here. one of my answers is negative 5 plus 7 divided by 4. And my other answer is negative 5 minus 7 divided by 4. So negative 5 plus 7 is 2. And 2 over 4 is 1/2. And then negative 5 minus 7 is negative 12 divided by 4 is negative 3. So those are my two answers to this problem. So that could have been factored, but if you didn't want to factor it, the quadratic formula will always work for you. Let's keep practicing. 2 more problems. So notice on number 3, it does not say that it's equal to 0 yet. So we're going to make it equal 0, and then we can put it into our formula. Negative x squared plus 6x plus 2 equals 0. We have to add 2 to both sides to move it over. Now, a is the number in front of x squared, so that's negative 1. B is the number in front of x. C is the constant, the one without any variables. So to solve this, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So carefully substitute your numbers in. So I've got negative 6 plus or minus the square root of whatever this is. Let's check it out. 6 squared minus 4 times negative 1 times 2 is 44 over negative 2. I think I can simplify the square root of 44 because 44 is 4 times 11. And I know that the square root of 4 is going to give me a 2 outside, and the 11 will have to stay inside. So this becomes negative 6 plus or minus 2 root 11 over negative 2. Now I'm going to notice, like in the previous question, these numbers are all divisible by 2, or in this case, negative 2. So negative 6 divided by negative 2 is going to be 3. Now this is positive and negative 2. So when I divide by negative 2, I still get positive, negative, but it's 1. So that square root of 11 stays there. And negative 2 divided by negative 2 is 1. So we're done. 3 plus or minus the square root of 11. All right, one more. Let's make it equal 0. 4x squared minus x minus 2 equals 0. And let's identify a, b, and c. A is the number in front of x squared. B is the number in front of x. Be careful, that's a negative 1. And c is the constant. X equals, now it says negative b. Well, b is negative 1. So negative b is going to be the opposite, which is positive 1. Plus or minus the square root of. So negative 1 squared. That's why I put it in parentheses, because I know what my calculator is going to do with that. Minus 4 times a times c. C was negative 2. All over 2a. All right, this looks interesting. Let's find out what's under our square root. So I'm going to put my negative 1 in parentheses before I square it so that my calculator does what I want it to. Minus 4 times negative 2. And I get 33. And my denominator, 2 times 4, is 8. So the square root of 33 does not simplify, So I believe I'm done. So we've learned how to solve quadratics by factoring and by using the quadratic formula.